This is day 19 of AMC 10 analysis, so I go over AMC 10 problems. Today we're going over the 2025 AMC 10B problem 17 and 18. Problem 17. Consider a decreasing sequence of n positive integers that satisfies the two conditions. Average of the first three terms is 2025. For k between 4 and n inclusive, the average of the first k terms is 1 less than the average of the first k minus 1 terms. What is the greatest possible value of n? So if we assume the nth term of the sequence is xn, the first condition translates to x1 plus x2 plus x3 divided by 3 equals to 2025, or x1 plus x2 plus x3 equals to 6075. Then we can plug in increasing values of k into the second condition. For k equals to 4, we get x1 plus x2 plus x3 plus x4 divided by 4 equals to 2024, 1 less than 2025, or x1 plus x2 plus x3 plus x4 equals to 8096. Then subtracting this from the first equation, get x4 equals to 2021, then plugging k equals to 5 into the second condition. Doing the same thing, we get x5 equals to 2019. In general, the preceding terms of the sequence are 2 less than the previous one, so if x4 is 2021, likewise, x3 is 2023, x2 is 2025, and x1 is 2027. Now we have to stop the sequence once its terms become less or equal to 0, because then it isn't a sequence of positive integers anymore. So using the formula for the nth term of an arithmetic sequence with the first term 2027 and a common difference -2, we can set this greater than 0. In solving this, we get n is less than 1014.5, but n has to be an integer, so we round down to 1014, which is our answer. Problem 18. What is the ones digit of the sum floor square root 1 plus floor square root 2 plus floor square root 3 all the way up to floor square root 2025? So floor x is the greatest integer less or equal to x. Writing out some terms of the expression, we find that in general terms n squared to n plus 1 squared minus 1 equal to the square root of n, where n is a square number. Writing out the sum, we get 1 times 3 plus 2 times 5 plus 3 times 7 all the way up to 44 times 89, which can be written as a summation sigma n equals to 1 up to 44 n times 2n plus 1, which can be derived from the fact that from term n squared to n plus 1 squared minus 1, there are the absolute difference of those 2 plus 1 terms. Then we can expand and separate this into two summations as shown. All the squares up to n squared can be summed as n times n plus 1 times 2n plus 1 divided by 6, while all the positive integers up to n can be summed as n times n plus 1 divided by 2. Since these summations go up to n equals to 44, we can plug that into these formulas and know that we have to multiply the formula for the squares by 2 since it's 2n squared. But we also excluded a floor square root 2025, which only appears once, and this equals to 45, which we have to add onto the sum, and getting the ones digit of this, we get 5.